So, welcome back, students. Uh, Welcome to the lecture series on signals and systems. This is a continuation lecture for the classification on even and odd signals. Previously, we have classified the signals based upon their symmetry to even and odd signals. Similarly, now I would like to add one more point, an important point about this even and odd signals. Generally, any signal x of t, any signal like x of t, can be expressed as the sum of even and odd components. That is, x of t can be expressed as a sum of even and odd components of the signal, and where xc of t represents even components and xo of t represents odd components of that signal. And let us evaluate these even and odd components and see what is the formulas and how to find out these uh, even and odd components of a signal. Let us consider x of t is equal to xe of t plus xo of t, the statement that what we have written above. So now, since this is true for x of t, this should also be true for x of minus t. And during that particular, when I substitute t with minus t, this becomes xe of minus t plus xo of minus t. And for even signals, you know that this can be simply written. Since for even signals x of t is equal to x of minus t, I can just write this as xc of t. And for odd signals, xo of minus t is equal to minus of xo of t. Therefore, I write something like this. Therefore, this x of minus t can be seen as xc of t minus xo of t. I shall number these equations as 1 and 2. And now by adding 1 and 2, I get the components x of t plus x of minus t. I get it as 2 into, I could clearly get it as 2 into xc of t. Because whenever we add, we get these odd components cancelled out each other, and we are left with 2 times xc of t. Therefore, from this knowledge, you can always find out your even components of the signal as xc of t is equal to x of t plus x of minus t by 2. Okay, xc of t is equal to x of t plus x of minus t by 2. And similarly, if we subtract instead of addition, if we subtract the signals, the 1 and 2 equations, x of t minus x of minus t, I get it as, uh, you could clearly see that it will be equal to 2 times xo of t. Okay, we could get that it as xc of t plus xo of t minus xc of t minus of minus plus xo of t. Therefore, xe of t gets cancelled and we are left with 2 times xo of t. And xo of t can be now evaluated as x of t minus x of minus t by 2. Okay, and this particular equation gives us the odd components of the signal, whereas this equation gives you the even components of the signal. And when added together, xe of t plus xo of t, this will result in x of t itself. Similarly, this can be adapted for discrete time signals as well. And you can always write xe of n is equal to 1 by 2 times x of n plus x of minus n. And for odd values, odd components of a discrete time signal, you can use the same equation and rewrite it as 1 by 2 times x of n minus x of minus n. The product, I would also try to add 2 more points, and especially you need to actually consider this. The product of 2 even or odd signals, okay, product of either 2 even signals or 2 odd signals, however you consider the product of 2 even signals or odd signals, is once again going to be a even signal itself. Okay, it is going to be an even signal. And similarly, product of a even signal and odd signal will be a odd signal. Okay, that means if you would like to find out the product of even and odd signal, then the resultant signal will be a odd signal. We can also prove this very easily. Okay, so let us consider, I'll just try to show this proof of this even signals. You could see that if x1 of t and x2 of t are two signals which are both even in nature, then what happens is x1 of minus t should be equal to x1 of t. As well, you could also see that x2 of minus t will also be equal to x2 of t. Therefore, if you calculate x of minus t, that is equal to x1 of minus t into x2 of minus t, that is equal to x1 of t into x2 of t. Since from this particular relations, you can write this, and this is equal to x of t itself. That means we have started with x of minus t, and we have arrived at the same x of t signals. Since x of minus t is equal to x of t, I can say that the product of these two, either even signals or even signals, is also a even signal. And this can be shown with the same odd signals also, and this turns out to be the same. Okay, and similarly, if you are considering, okay, I have considered them to be even here. Okay, and similarly, if I consider x1 of t to be a even signal and x2 of t as an odd signal, okay, so then you have that condition x1 of minus t is equal to x1 of t, and x2 of minus t is equal to minus x2 of t. These are the conditions based upon their nature, and therefore, if we would like to find out x of minus t, that is nothing but the product of x1 of minus t and x2 of minus t, I could see that this can be written as minus of x1 of t into x2 of t, which is equal to minus x of t. Okay, this is when I represent this product as x of t, just I'll be able to get this. That means for x of minus t, I'm getting it as minus x of t. Therefore, the product of a even signal and an odd signal is going to be odd signal. Every signal need not be either purely even signal or purely odd signal, but every signal can be decomposed into sum of even and odd parts. This, you need to remember this point. Every signal need not be either purely even or purely odd, but every signal can be decomposed into even and odd components.